Colton, we are doing notes in Algebra 2 for section 1-4. I will send them to you, or you already have them. Sketching graphs is what we're doing. We're not going to be doing so much comparing functions because we're going to skip example 4 and 5. So we're just sketching graphs today. We will not do the other one. So like it's not like Monday we'll do comparing functions. We're just going to skip that part altogether because we do some comparisons when we're sketching graphs. So we're just going to sketch graphs today. This box, I'm going to write lots of information off to the side of this box. So be ready for that. Domain is the first key feature that they say. What is domain? The x's. This tells you left and right. So if I say the domain is this, you'll say that's the left it goes and that's the right it goes. Okay? Range is y. That tells you
Up and down.
up and down. How far up and down does it go? Okay? The intercepts. There are two kinds. There are x-intercepts and y-intercepts where they hit the x-axis. I'm going to say x-axis, y-axis, intercepts. So I'm just going to do that. I don't know. Intercepts, where it touches the x or y-axis. Now, real quick question. We've talked about this already before. How many x-intercepts can you have? How many places can he intercept the x-axis?
Infinitely.
He can do as much as he wants to. If you keep having up and down and up and down and up and down a graph, it will touch a bunch of times, right? How many y-intercepts can you have? One. Why not more than one? If he goes like this, right, he's not going to pass the vertical line test, so he's not going to be a function. So there, you will only have one y-intercept, unless it's not a function. You only have one y-intercept, but you can have a bunch of x-intercepts if you want to, okay? So only one y-intercept, all right? Let's talk about symmetry, okay? The two types of symmetry were line symmetry and point symmetry. Line and point. For point, I'm going to say upside down, because that's what you do. You flip it upside down. Line symmetry is fold in half. Okay, you fold it in half for line symmetry. You flip it upside down for point symmetry. And you're looking to see if it's the same on either side, right? Line symmetry, point symmetry. Okay?
Do we get to use our notes for tests?
Sometimes. Sometimes we'll do like a note card or something where we'll all condense it and I'll help you fill your note card out and then I'll let you use that part. I don't know. We'll see. I haven't decided yet on this chapter.
Book, I think we should.
You think we should? Okay. End behavior. As x goes to infinity, the y coordinate is doing something. We got to fill that in. As x goes toward negative infinity, the y's are doing something. We were doing this in calc today. Kind of.
Why are we using it?
But we were doing limits, but they're related to end behavior, so it's a little bit harder. Okay, so x goes to infinity, y goes to blank, x goes to negative infinity, y goes to blank. All right, extrema. These are maxes and mins. So I have a relative max, a relative min, an absolute max, and I have an absolute min. Do you need clarification on which ones are which? Or do we understand the difference between relative or absolute? Are we good? Jake's causing problems over there in the corner?
Yeah.
I believe it.
I'm thirsty.
Oh my
You wouldn't give me water.
goodness. Go get a drink of water.
Dude.
Go drink from the fountain.
Okay.
Go.
It's
Crazy. Okay. I'm gonna get a drink before I do these last two.
Go fast.
I'm putting the block.
Good call. About out of water. All right. All right. Increasing, decreasing versus positive, negative. These people get this confused all the time. Don't do that. You're gonna cause problems.
Don't blame me.
Okay. Increasing, decreasing, positive, negative. People get this confused all the time. They call them the wrong thing. Okay. Increasing means it's going uphill. Uphill. Decreasing means it's going downhill. Okay, increasing uphill, decreasing downhill. Got it? Okay, positive means it's above the x-axis. Negative means below the x-axis. Okay, I'm going to draw some pictures. my coordinate plane. Ready? Alright, I'm gonna draw a linear function that goes like that, right? Okay? The x-axis is here. This chunk right here, is that increasing or decreasing? Increasing. But it is also positive. This guy is what? It's still increasing. Right? It's still going uphill from left to right. Right? But he is negative because he's below the x-axis. Make sense? So don't get them confused. Okay? Let's do the other one. What?
Spelling neck because you put N-E-C.
I just forgot to close my G. Alright, there we go. And now I forgot to do my other. You keep distracting me. I have enough time as it is. Alright, here we go. This guy right here, there's another linear function. This chunk right here, decreasing and positive. Okay, this guy is decreasing and negative. Okay, so don't get them confused. Got it? Okay, there's how that works. Alright? It always cuts off where it intersects the x-axis. That's where it switches from positive to negative. Got it? Positive, negative. Increasing is going uphill, decreasing is going downhill. Alright, so sketch a linear function. Alright, we're going to use our context clues in here. And this is going to make our homework assignment go a whole lot faster. Because when you have a linear function, they're going to give you tons and tons and tons of information. But if it's a linear function, usually I can graph it after like the first two things. And I don't even have to read the rest because I know it's a linear function, it's going to be a line, right? If they give me a couple pieces of information, I can plot it and then I don't even have to read the rest, right? So I'll show you how that works, okay? They went ahead and graphed this one for us. So the first piece of information it tells me is that the y-intercept is negative 70. The y-axis right here, this is my y-intercept. So that is this piece of information. Negative 70. I put a dot there, right? Okay. Then we know it's linear. It tells us that. So I know that it's going to be a line that's going to branch off from that dot somehow, some way, right? All right, here's the next piece of information. Positive, negative 30 is where it switches from positive to negative, okay? So do you see where it says negative 30? I'm going to put a dot there on my line, or on my graph, and it says when x is less than. Okay, when x is less than, is that on the left side of negative 30 or on the right side of negative 30? X is less than. So this is on the left side of negative 30. It is doing what? Positive. On the left side of negative 30. Negative 30 is this dot. On the left side is positive. Is it above the x-axis on the left side of this dot?
Yeah.
Right here? That's positive. Okay? The left side of that dot. Okay? So I have those two dots. I know it's linear. At this point, I can just go, whoop. I don't even have to read these. Right? Okay, let's check them to make sure that they still apply. So decreasing, it's decreasing for all values. Is it decreasing the whole time? Yes, it's not turning around and going back up, okay, because it's linear. And the end behavior, as it goes to the right, it's going down. As it goes to the left, it's going up. Right side is going down, left side is going up. True? Yeah. I had a graph after like the first couple pieces of information. We were good to go, right? For linear function, that makes it really nice. Let's graph the next one. This one's non-linear, so it's going to have some like humps and bumps in it, okay? All right, so here we go. The y-intercept is 0, 3. Graph it. That dot, put a dot right there. Y-intercept is 0, 3, okay? It is non-linear. I can't graph that yet. I just keep that in the back of my mind that I know it's not going to be a straight line, okay? And then it's a continuous function. What does that mean? It's not little dots. It's connected, right? It's going to have like be a connected line, okay? All right, positive for all values of x. What does positive mean?
Above x.
It's above the x-axis. So I'm going to do this. I'm going to say he does not live there at all, right? You don't have to do that, but I'm going to do that to aid myself so that I know I'm not going to graph anything below that, okay? Decreasing for all values of x. Oh, such that x is less than 0. Got it, okay? What does x less than 0 mean? On the left side of 0. So on the left side of 0, it's decreasing. So I know he's touching at this point right here. On the left side of that point, he's going downhill. You can have a visual in your mind of what this is going to look like. He's going downhill until he hits that point. Maybe something like this. Is that decreasing on the left side of that point?
Yeah.
Yeah, decreasing on the left side of 0, so he's going downhill. Okay, let's do something else. It has a minimum at 0, 3. 0, 3 is the dot that I have already put on here. We said that this was a minimum point. So what has to happen on the right side? It's got to go back up at some point, right? Okay, and as it goes to the right, it is going up, and as it goes to the left, it is going up, right? So it could be a parabola. Now, it doesn't tell me necessarily on the right side what's happening too much, so could I do that instead? Is there still a minimum here? Is it still going up there? So who's to say there's not an extra like couple humps in there, right? Right? That could be what it looks like, right? You could just make it a parabola, that's all the information it gives me, but it doesn't say that there's not things over there, right? So you could make your graph look a little different, as long as you're fulfilling all those requirements, make sense? I would maybe just put it as a parabola, you know, whatever, but you could make it fancy. Got it? That's a non-linear graph, non-linear, okay? All right, and now we have a real world example. So they have a story, and we're gonna graph this story as they go along and tell it, okay? I might, do I wanna follow the paragraph? Maybe, we'll see. Hay is the person's name. Is that a girl or a boy? Hay?
I don't know.
H-A-E? Does it say she? She, Hay, is a girl. Hay is test driving a car she's thinking of buying. She decides to accelerate to 60 miles per hour and then decelerate to stop. So she's going up in speed to 60 miles an hour, and then she's going down in speed. She's just test running it, going down the road, starting, stopping, okay? It takes her 15 seconds to reach her maximum speed. So let's go down here. 15 seconds to reach her maximum. Where are we starting this graph at, by the way? 0. Like, we better start at 0, because that means if we didn't start at 0, then you would be jumping into a moving vehicle, right? Like, that wouldn't be good. So we're starting at 0, and it takes her 15 seconds to reach her maximum speed. So 15, 60, we're going to put another dot there. Are we going straight up, like as a straight line from one to the other? It's non-linear? Well, okay, that's a good question, or a good thought. The whole graph is not going to be linear, but within it, each part could have like pieces that look like lines. Does that make sense? Yeah? So it doesn't matter. We could make it a straight line, but I'm going to do something like this. Maybe something like that, right? Because as soon as you get like up to a higher speed, you kind of level off until you get to a coasting place, right? Does that make sense? Okay. So I'm going to do something like that. It's not quite a straight line, but it's doing something like that, okay? And let's see. To reach her maximum speed and 15 additional seconds to come to a stop. Use the key features to sketch a graph that shows the speed. So does she stay at that speed for a long time or not? No. Huh.
Because
She's just going up and going back down, but she could stay at that speed for a little while and then come back down. Does that make sense? But it doesn't say that she does. So evidently she's just reaching that speed and coming back down. And it takes her how long to do that? 15. So where would we be at then? 30. So we're doing one of those. Yeah. So that's kind of making, my parabola doesn't look very straight, but it doesn't have to. So that's kind of what he looks like, maybe. I don't know. Okay, make your graph look better than mine. Mine looks terrible, okay? Non-linear function, okay, like Macy said. But we have fulfilled all of the information up above there. It doesn't say anything more than just that. That's it. Huh, that's not too bad. Okay, the y-intercept. We have a couple, 2 minutes? Okay, the y-intercept, she starts her test drive at 0 miles per hour. It is non-linear. She has a maximum at 60 miles per hour. It is increasing and then it is decreasing after that. The end behavior. It doesn't have end behavior because we're starting and stopping, right? It's not going to continue on forever. So there is no end behavior here. Okay? There is no end behavior in that little blank. All right, what else? That's it. 4 and 5. We're not doing those examples. Yeah, 2 through 10 the evens and 18 and 22. Okay? If the graph doesn't fit on the little graph paper, flip it over and do a different graph. Like if the units aren't gonna be right, especially for like that number 10, I think, maybe. 10 is a story problem one, so maybe those graphs aren't gonna be the best. Alright? Whatever you decide, it doesn't matter. Okay? Alright. Goodbye, Colton.